Good morning, everyone, and thanks for coming. This is How Good Management Creates Bad Technology, and my name is Darryl Campbell. And I want to start by taking you back to the year 2010. If you remember, there was no Snapchat, there was no Instagram, there was no Tinder, and it was the year that I first joined the tech industry. Back then, it felt like tech was the underdog. Of the 3 largest companies in the world, of the 10 largest companies in the world, only 3, that is Microsoft, Apple, and Google, were on the tech list. And it was really a time of innovation and finances second. But I think lately we've gotten the formula a little bit backwards. We've confused making a lot of money with doing things that actually help people. And I think increasingly it feels like we're a part of the financial industry that makes technology rather than a separate industry altogether. And I see a couple nods out there, so hopefully you agree a little bit. Now, don't get me wrong. You obviously have to pay attention to finances when you're part of the tech industry. In fact, I've been a part of 2 startups where that didn't happen. One where I was the chief growth officer of a little seed stage startup, and the founder basically blew all our money at Art Basel. And if you want me to tell that story, just come up afterwards. So that was one. And then there was another Series D that was in an industry where basically the bottom dropped out of the market, and we weren't able to continue operations. So you absolutely have to pay attention to finances, of course. But if you think about, let's say you've founded a new consumer-facing app. So in the initial stages, you look at things like installs and opens and retention, basic set of metrics. Let's say your business gets more successful, and then you start thinking about, all right, how do I keep people engaged? So you get a second set of metrics like MAU, revenue, time in app, and so forth. Eventually, hopefully, you continue to grow and you get more and more exotic over time. So you look at DAU over MAU, LTV, but basically all of these derived metrics. And then you get to the point where you've developed a certain set of measures that allow you to tell how your business is doing that really don't make sense anywhere else. So I'll give you a couple examples from my career. So when I was at Uber, we talked a lot about surge rate. If it's too low, then you don't have enough. If it's too low, then you have too many drivers for the amount of riders, and vice versa if it's too high. Similar sort of thing at Tinder. The swipe rate was essentially a good predictor of someone's success, where if they were getting too many matches, then they weren't going to pay for it. If they were getting too few, then they were going to churn. And when I was at Amazon, we looked a lot at things like spot price elasticity of demand. So basically, how much margin could we give up in order to get a certain set of market share? But these financial abstractions don't really change over time. And if you look at the way that, for example, corporate executives are compensated for the way that they run their business, it's really things like if your stock price gets to X, you get $10 million. And if it gets another $10 a share, you get another $10 million, and so on. And the problem with that is, if anyone's heard this before, this was an English mathematician, I think he's from the 19th century, named Charles Goodhart. But he said, when a measure becomes a target, it ceases to become a good measure. In other words, human nature being what it is, if you say your goal is to get $10 million in revenue, then you're going to do that thing no matter what. In other words, you're going to go after it, even potentially to the harm of the rest of your business's ecosystem, because that's the only thing you're incentivized for. And I worry about the way that we've kind of overly focused on things like revenue, profitability, share price, basically all of these financial abstractions, because they come from a very different world. People always think about the stock market being an immutable law of business, just like Adam Smith's invisible hand. But in fact, if you actually look at it, it's really only developed in the last 80, 90 years. So everybody always points to Milton Friedman. He wrote this op-ed in the New York Times in 1970, and he said, there's a one and only one social responsibility of business to increase profits. he popularized this idea, but it wasn't really the first time that it was ever sort of laid out. Here's an American sociologist named James Burnham, and he was writing in 1941 at the very beginning of the United States' involvement in World War II. And he had already identified a shift away from the sort of Gilded Age, robber baron business economy and sort of management style of people like J.P. Morgan, John D. Rockefeller, Andrew Carnegie, into this professional class that believed that there was one universal set of metrics and one universal way to run a business that you could measure perfectly. And that measurement were these financial abstractions. So this is the time when, for example, the P&L was invented. This was the time when GAAP principles were first laid out. And over time, those have become kind of the way to measure a business. But they were really from a different time altogether. And really kind of the originator of it was the Austrian School of Economics before University of Chicago, like Austria, laid out by Ludwig von Mises here, where basically he's saying, let's say you're running a railroad or a factory or even an integrated multinational company. You basically have to figure out how to measure your labor costs, your resource costs, your transport costs all together in order to essentially turn a profit in an increasingly globalized age. And that worked for a long time. But if you think about the kinds of companies that they were talking about and building this sort of operating system for management, they had limitations. So time, distance, the availability of resources, the fact that you couldn't just ship a car from Detroit to London in a day. They were also very differently sized and structured. So in 1950, when the Fortune magazine started creating what would eventually become the Fortune 500 list, the largest corporation on that list was about 10 times smaller than NVIDIA, Apple, whatever you want to peg as the #1 corporation today. And with that size came the ability to do things like influence legislation, regulation, and create other market-distorting factors that really wasn't available to, let's say, your Standard Oils and your General Motors back in 1950. So this ideology was really kind of an early to mid-20th century innovation, and it worked really well. It helped the United States win World War II, shift its economy from a peacetime to a wartime footing. It helped arguably win the Cold War. But if the underlying fundamentals, the structure, the products that you're making change, why do we still look at this 20th century model for the way that we sort of run our business? And it's especially important when it comes to technology. And I worry about this because you can already see how this kind of profit at all costs is starting to distort markets, corporate incentives, and so on, even before technology became a thing. So in the 1950s, 1960s, it was big tobacco and cigarettes. So if you've ever watched the show Mad Men, you know, the first episode, they're all portrayed like Virginia country gentlemen. But in fact, in the era of the biggest expansion of big tobacco, they were financiers and bankers and lawyers trained at places like Yale and Columbia and Duke. So these weren't just these gentlemen from Virginia, they were actually this managerial class. The same sort of incentives also caused the big proliferation of polluting chemicals, including DDT, which was where Rachel Carson wrote her 1962 book, Silent Spring, because there was really no other way available to essentially force some of these companies to pull back on this huge environmental hazard that almost led the bald eagle to go extinct. Today, healthcare and insurance have been in the news recently. You think about I know the stat that everybody's throwing around is claim denial rate. I have a friend who works at, I'm originally from Oregon, I have a friend who works at Oregon Health Sciences University, and they were saying that some of these insurance companies deny up to 50% or more of claims. And it's not because the claims are bad or the people aren't deserving of them, it's just that someone made a business decision to over-index on profitability even if it creates these externalities, because the externalities don't really appear on the P&L. What does it matter to big tobacco if someone gets lung cancer? They still keep smoking. What does it matter if the bald eagle goes extinct? That's not a factor into a chemical company's business. And so I'm increasingly concerned that as the tech industry has gotten big and influential, it's also entering its big tobacco phase. Let's put it that way. So I'm going to take you through a couple of case studies here to show you exactly what we mean. One of them is going to be a big industrial company that's integrating software for the first time. The other one's going to be a cutting-edge unicorn that also had something that had similar disastrous results. So Boeing, the world's largest airplane manufacturer. For its first 100 years, Boeing was an engineering company first. It made the first commercial jet airplanes in the United States. It basically reduced the rate of air crashes from something like 6 in a million to 0.6 in a million. And it was basically because they focused on making great products first, even if that didn't mean that they were going to have a successful business. And even when they did things like merge with their last domestic competitor, they couldn't really get that sort of profitability index on the right side. So in 2006, they hired a former consultant, a former GE executive named Jim McNerney, and he brought that managerial style to Boeing for the first time. He was the first CEO that they ever hired from outside the company. And while they continued to launch airplanes that looked great and definitely made a profit, he did so by undermining the things that made Boeing good in the first place. This is a very standard playbook. So for example, reducing labor and CapEx by outsourcing the manufacture of components and systems. Devolving R&D onto individual vendors, so you don't have to pay for it. You just give someone a one-pager and then they say, okay, go make me a landing gear or a piece of software or whatever. Aggressively replacing vendors that couldn't keep up with their cost structure and cost savings. And then finally, requiring every single product decision and engineering decision to have a financial justification, which was the first time in Boeing's history. This became a problem when Boeing had essentially an existential threat from its only remaining global competitor, which is Airbus. So you've probably all flown on a 737 before. It's the most popular airplane in the world. It's very safe, very rugged. Well, previously to this, you shouldn't have worried if you were ever sitting in a 737. That's how safe it was. But in 2010, when Boeing faced this competitive pressure, it was already a 50-year-old airframe. And as a 50-year-old airframe, it had a massive amount of technical debt. On the other hand, there's this huge commercial pressure to keep airplanes what they call within type. But basically, if you think about a car, for example, like your Corvette, as long as it's got a big engine and 2 doors, you can call it a Corvette. On airplanes, you have to keep the size, the handling characteristics, and a lot of other things the same way, or else regulators are going to call it another airplane. And pilots aren't generally certified on every airplane. They're certified on a specific type. So there's a huge commercial pressure to basically keep 737s. And you know what? Boeing almost succeeded. They were still a great engineering company, even 4 years into this managerial tenure. They made the 737 more efficient. They added a couple more seats in there, which I know as passengers you're less happy about, but airlines love it. And they basically kept it 95% common with previous types of 737s to keep it within type and to meet that commercial pressure. Until about 5 years into development, they found out that there was a problem with the aerodynamic profile of the airplane. So I won't get into it too much, but essentially when the airplane is climbing and turning at the same time, these new larger engines caused caused the airplane basically to kick its nose up. And while this never put the airplane in danger, Boeing was afraid that it would change the maneuvering profile enough that potentially a regulator might call it something else. Now, as anybody who's ever worked in product knows, you can do something good, you can do something fast, and you can do something cheap. but you can't do all three. But in the mind of this managerial executive who knew P&Ls, who knew finances, who didn't know airplanes and didn't know software, they just said, fix it with some code. Just like, write some code, you'll fix it. And I think a lot of us have been on the business end of such decisions before, so I think it'll be pretty familiar to everybody. They created a piece of software called MCAS, the Maneuvering Characteristics Augmentation System. Basically, it tried to cancel out that nose-up tendency. And they thought, pretty good. They wrote it in a couple of months, they deployed it. They sort of hid it from regulators because they called it something else because they thought, well, it's not a big structural change, so let's just kind of sweep it under the rug. And for a couple of years, it looked like it would fix the problem. So I'm going to read to you now a little bit from the accident report of the first Boeing 737 crash in Indonesia, just to give you a sense for what happens when you don't necessarily think through your software and you build it for financial reasons. So on October 28, 2018, a brand new Boeing 737 MAX operating as Lion Air 610 took off from the international airport in Jakarta on a standard domestic route about an hour away. 2 seconds after takeoff, the stick shaker on the captain's side of the airplane started rattling. Now, stick shaker is designed to do a very specific thing. Again, big aerodynamic problem, but essentially if you've ever thrown a paper airplane and you know how it curves up and then at a certain point it just kind of tumbles to the ground, so that's called a stall. And when airplanes get close to a stall, because it can happen to 75-ton airplanes in addition to paper ones, this thing goes off. But the pilot was a professional. He knew that nothing in his climb profile, nothing in his flight pattern was off. And so he just decided to keep flying because that's essentially what you're trained to do, is as long as the airplane's in the air and there's not an immediate emergency, keep on flying and figure it out. 8 seconds later, his first officer noticed that there were 2 alerts on the primary flight display. So one said the altitude systems are out of sync, one said the airspeed systems are out of sync. And that's normal. Every airplane is designed around the principle of redundancy. In other words, no one system failure should ever cause the airplane to be in danger, especially not a critical system like the instruments. So it's relatively normal to see some kind of disagreement, and again, you just troubleshoot it in the air. So they decided to fly the airplane into essentially a little holding area outside of the main traffic flow into and out of Jakarta. But when they did, and when they started their turn, the airplane kicked over into a 35-degree bank, alert sounded in the cockpit, and it dove straight for the surface of the Java Sea. Now the captain, being prepared for these kinds of emergencies, pulled back on the stick and got the airplane out of the dive. But it was something that no 737 would ever do. It was not a situation that he had trained for specifically. Pilots are trained on thousands of these kinds of emergencies, and this was one that did not look like anything else that he had ever been trained for. What was happening is that MCAS accidentally thought that the airplane was in one of those tight climbing turns. The reason for that was that the previous day, a mechanic had replaced a sensor, just one, on one side of the airplane that essentially fed it what's called pitch angle data, so basically how far up the nose is going. And he forgot to calibrate it. Standard human error, sometimes it happens. But MCAS, because it was written by a vendor who was new to the airplane, because they were cheaper, because they were trying to save costs for other reasons, and because, remember, they wanted it to be a magic fix that could be done fast and cheap and well, it had no error correction built into it. It didn't know that sensors could fail. It had no access to any other system that would tell it, like the captain did, that everything else is fine, it's probably you're the problem, not this aerodynamic anomaly. And so as the pilots continued to try and recover their airplane, MCAS kept going off. Past 10 times, 15 times, 20 times. If the sensor reading it had gotten were actually true, Lion Air 610 would be flying at about 50,000 feet of altitude, which is about 3 miles above the physical capability of the airplane to actually function. But it didn't know that. It just said, I'm going to believe whatever this sensor tells me because that's how I was programmed. For almost 10 minutes, the pilots fought the airplane. 20 dives, 23, 24. At this point, the captain was tired. Every time the airplane dove, it picked up airspeed. And every time it picked up airspeed, more air was rushing over the control surfaces on the outside of the airplane. It was becoming physically harder to pull the airplane up. At this point, he had to fight with the equivalent of about 100 pounds of force, which is about how much force it takes to restrain a fully grown Rottweiler by the leash, every single time he needed to pull the airplane out of this dive. So he went back to his first officer. He said, I'm going to switch. We need to figure out what's going on. You fly the plane. I'm going to take over the radio. They put out an emergency call, but MCAS continued to activate for a 24th time, 25th time, 26th. After 26 activations, the airplane was in a 30-degree downward dive. It was traveling at almost 500 miles per hour, which is about 80 miles an hour faster than the airplane is designed to do. It was literally coming apart around these pilots. And MCAS had no idea that any of this was going on because it wasn't designed for redundancy, for error correction. And this is basic stuff that they had just forgotten to do because they were so focused on hitting the financials. But by now it was too late, and Lion Air 610 was heading for the water, descending at about 4,000 feet per second. On the recording of the cockpit voice recorder, you can hear the co-pilot, half a second before impact say, "God is great," and then in the data recorder you can see he lets go of the controls, and it impacts the surface of the Java Sea, obliterating everybody on the airplane in about half a second. Now you would think that after this kind of crash, Boeing would do the thing in the interest of public safety, ground the fleet, figure out what's going on, make sure that people aren't at risk. But that's not what happens. Within days of the crash, executives and salespeople fanned out all over the world to say to the media, this airplane is safe, it was the pilot's fault. And then to airlines, keep buying it, we know what happened, it was really nothing to worry about. They gave a very limited guidance to pilots saying that, oh, there's this mysterious condition that you might experience. Just do one or two things and you'll be fine. And they continued to sell airplanes. In fact, after the crash of Lion Air 610, they sold almost 210 additional aircraft, including a large order worth more than $1 billion to Lion Air itself. That's how good their sellers were, because they had focused for so long on protecting the business and keeping the sales pipeline going. And then it happened again. Ethiopian 302 took off in March of 2019. The same thing happened. Stick shaker activation right after takeoff. Warnings from the altitude and airspeed procedure. This time, the pilots had actually trained for it. They had read Boeing's bulletin. They followed it to the letter. They even had done some simulator runs of exactly what would happen. Despite that, they still crashed. Boeing, in its regulatory filings, had purposely, or, well, I don't know if I can legally say purposely, but they had underestimated the severity of the problem. They had put some numbers together for the FAA that said there was a less than 1% chance of another crash in the next 6 months. And regulators just said, okay, that looks good. Let's check it off. And in fact, if you go back and do the numbers with real failure rate, real crew response, essentially their ability to successfully respond to an MCAS activation, the actual chance of a crash was 20%, more than 20 times what Boeing had said officially to regulators. And you can read the emails that their executives sent and their board members sent, that they were more concerned about what they called suppressing negative chatter than prioritizing product safety. Meanwhile, the software vendor who actually made MCAS, had no way of pushing back on Boeing because they had essentially sold the license to Boeing. They said, okay, it's off our plate. Boeing had said, well, we've let somebody else program it, so we're not really responsible for it. And basically, safety became somebody else's problem as an outgrowth of this outsourcing, financially minded management profile. What really gets me is that none of the errors that caused MCAS were all that complicated. They could have easily been fixed. But it didn't have redundancy or error detection. Remember what I said about airplanes having redundancy as a design principle, and this was ignored. It could get caught in an infinite loop, which if you think about it, if an airplane's in a tight climbing turn, that's only going to be a few seconds worth. So there's really no reason to have it activate more than one, maybe two times. But that wasn't built in to the software. MCAS was given control over the largest control surface on the airplane, which is the horizontal stabilizer, but that didn't raise any red flags. They just said, oh, the math works out, let's run with it. And finally, MCAS was copied from another airplane design. It was actually transferred from a military airplane with a different sensor architecture using MCAS for a different purpose. Why did they just copy code from somebody else? Because it's cheaper. So I think this is an example of why this financial mindset really can't protect people against these safety concerns. I mean, if you had gone into the Boeing board of directors meeting where they approved the 737 MAX, and you had a crystal ball, you could see exactly what was going to happen. You say, this is going to cost you $80 billion in fines, in legal fees, in canceled orders, in brand reputation damage. I guarantee you, you would have been laughed out of the room. And if you had said, you know what, if we're going to mitigate this, if we're going to do it properly, I need another $9 billion versus the about $1.5 billion that it actually cost to make the MAX, you would also have been laughed out of the room. Again, safety was somebody else's problem. It was just assumed. Hold that thought for a second. I'm not suggesting that anybody now go work for Boeing, but I think it's a useful metaphor for the way that we're approaching technology. And I'll explain more about that in a second. But first, I want to talk about Uber. And I don't know if any of you have successfully gotten a Waymo here, but I think that's pretty cool. I haven't had a chance to do it yet. But if you remember, about 9 years ago, Uber was supposedly on the cusp of creating a self-driving car. And this is actually when I was at Uber. In fact, if you read the book or have seen the TV series Super Pumped, that's exactly the environment that we're talking about here. So if you remember, Uber was a valuable unicorn making billions of dollars, but it also was losing money at an incredible rate. And one of the ways, or actually the way, that Uber was going to solve this P&L problem was to get self-driving cars out there. So self-driving cars don't need to take bathroom breaks. They don't get in fights with riders, sort of. They don't want to go home and see their families. They can run 24 hours a day. So from a financial perspective, if you're losing money on every car ride and you can do something that is both more efficient and more financially appropriate for your business model, then why wouldn't you? Oh man, look at that P&L. That's bad. Okay. But you think about Uber. It's a B2C app with most of the computing done on the cloud, with no assets. It's asset light. You basically devolve that onto your contractors. And this is the exact opposite of the expertise that you need to build a self-driving car. You need computer vision. You need onboard compute. You need someone to manage all of these cars. And you're trying to transplant this new vertical, essentially, into a culture of what I call results over principles. These are some of the little mantras that I remember from my time here. Give me a little bit of trauma every time I see them. But that's what we lived and breathed at the time. You were supposed to hit your target, go after it, no matter what. And we did. But by 2018, progress was essentially stalled. So Travis Kalanick, the founder of CEO, and Anthony Lewandowski, the head of ATG, which is our advanced technologies group, self-driving cars, basically, had both left. The cost to rig a vehicle had not really come down. the way that the software recognized objects was very limited, and it got tripped up by basic things like piles of leaves or shiny surfaces or not being able to distinguish between a picture of a car and a real car. Even so, Uber focused on what we called crushing miles. So essentially, get your cars on the road, get them driving as much as possible, and because the KPI was on these miles autonomously driven, the incentive was to keep them on safe routes that posed no problems, that really were almost impossible to screw up on. And by the way, still losing a lot of money. So again, we have financial pressure to innovate. We have new verticals and new types of expertise needed, and we have an existential threat to the P&L. So I want to take you to Tempe, Arizona in March of 2018. Tempe is a really great place to test autonomous because it's flat, it's the burbs, there's really not a lot of pedestrians out there, and the weather's generally good all the time, so you get a lot of miles driven. And on this particular night, it's about 9:30 p.m., we had a car going north on Mill Avenue. It's basically north of downtown, it's at the start of the burbs. 4-lane road, then about 600 feet away, we have someone named Elaine Hertzberg who's walking her bike across the road. While they're a couple hundred feet away, the radar suite on the car detects her for the first time. And she's got kind of a weird radar return profile. But it decides that she's a vehicle because she's larger than a person, larger than a bike, and moving laterally in a way that would suggest a vehicle changing lanes. So the car's in the right-hand lane, she's in the left-hand lane, no chance of collision. About 1.8 seconds later, LiDAR also detects her. So the radar, or the laser pings coming off of her, also classify her as a vehicle because, again, that profile is not really in that database of types of objects. And again, no course correction. 2.6 seconds before impact, LiDAR reclassifies her. And actually, every time it pings her, it classifies her as something else. So sometimes she's a vehicle, sometimes she's an other. And that has two problems. The first one is that each classification carries specific assumptions about where it can move, how fast it can go, and in which directions. And also, like a baby that doesn't quite recognize object permanence, every time it reclassifies her, it forgets everything about all of the other identifications. So it's like there are these objects blinking in and out of existence in front of it, because that's what the software did. And so it forgets the lateral track that she's moving and just says, okay, each time I'm going to recalculate where it is, where she's moving, what those assumptions are. And it just doesn't do anything, even though they're clearly, at this point, to a human observer, on a collision course. And there is a safety driver in the car, but it's nighttime and she's not yet close enough to be in the headlights, and this part of Mill Avenue doesn't have a lot of streetlights, so the safety driver doesn't see her yet. So 1.2 seconds before impact, and the first time the car detects her as a potential hazard. And again, Uber's business imperatives intervene. So Uber is not just building cars for the sake of building cars. They're building it to replace human drivers. And one of the things that a human driver does really well, for all of their financial downside, is that it makes a relatively comfortable ride. You don't have someone who's like, well, I don't know about you, but most of the time, you don't have someone who's like jerking across lanes and slamming on the brakes every 5 seconds. But Uber's cars tended to do that. They were trained on San Francisco, Pittsburgh, and they had a lot of situations where they're going at 15, 20 miles an hour, someone jumps in front of them, the car brakes to the point that a rider would become nauseous. And so we had built this rider experience limitation that said, if the car wants to emergency brake, you suppress that for 1 second. And if you're traveling at 20 miles an hour down the street at San Francisco, that's what, I don't know, 30, 40 feet of distance. But here we're going at 45 miles an hour with a 2-ton SUV. And we're saying that 1.2 seconds away, we're going to suppress the braking, the emergency brake, for a full second. So it continues on. 0.2 seconds before impact. They're about 75 feet away. For the first time, The rider experience rule is overcome. The safety driver sees her, and an in-cabin alert sounds. But by this point, they're basically traveling too fast to avoid her. They're already on top of each other. She got hit by, I think it was the right front fender of the car, dragged about 75 feet. She was the first person to be killed, the first pedestrian to be killed by an autonomous car. The same thing applies to Uber that applied to Boeing. The financials dictated the speed of technology. The effort KPIs overruled any quality KPIs. Uber being Uber, they weren't really going to listen to anybody else who said you're moving too fast, you're kind of ignoring best practices. And for the first time, Uber was actually operating a real thing, a 2-ton vehicle, for which it had no kind of culture of safety. So we've got the old school company deploying tech for the first time, and we've got the unicorn on frontier tech also deploying a new tech for the first time. And I'm hopeful that you've already sort of put it together that these are metaphors for the way that people are going to use things like generative AI, or the companies that are working on lethal autonomous weapons. Like, I don't know if you guys know this, but for the first time, a for-profit company in Turkey called STM deployed lethal autonomous weapons that basically were given full authority to use deadly force against people during the Libyan civil war in 2020. Nobody knows if they were programmed with safeguards against targeting civilians. Nobody knows if they were programmed with any kind of ability to distinguish between soldiers and children, or even if someone told them, like, the interface for it is essentially like a command and conquer game. You basically tap where you want it to go, it'll go there and it'll shoot whatever's in there. And we have no idea whether they're doing that safely or appropriately. Now, I'm generally an optimist about technology. I think it has a lot of liberating and sort of efficiency-gaining potential, but not under the regime of financialism. And here's why. You kind of think, if you're an engineer, you kind of think that somebody else has the incentive to be the adult in the room. But if you look at the way that executives are compensated, for the most part, their pay depends on financial performance. If you look at the way that boards of directors function, they're really there to protect the fiduciary interest, and it's extremely rare, even though it's technically part of their job, that they have the interest or even the ability to enforce some of these safety concerns. And of course, investors are seeking maximum returns, which is fine. That's what they're for. This last part, I think, is becoming increasingly important in the age of tech mega companies. That regulators lack the experience, lack the leverage, lack the expertise to really police some of these things. And when they do, all they're going to do is levy a fine afterwards. So if you remember the Facebook Cambridge Analytica scandal in 2016, 2017? About then. After investigating that, the FTC released its biggest fine in history, $5 billion. Anybody want to guess how long it takes Meta to make that much money? It's a little bit less than a day. So it's a rounding error. So they lack the leverage to do anything about it. So I'm afraid that with nobody else, you and people like you are going to have to do the hard work of actually protecting people against bad technology. The first part is, you kind of think of it as a reverse sabotage, but basically taking the responsibility to do things like add quality control, like add that extra layer of protection against bad technology. Because if you think about it, in the Boeing example, people can't opt out of flying a Boeing airplane. They don't have the market power to dictate what people are using. In the Uber example, the pedestrian didn't have a market power to decide if she was going to get run over or not. It just happened because the car was on a public street. The good news is that your boss won't know what you're doing because they're only looking at the financials. So if you can do it in such a way where you can actually build this stuff into your software, build these safeguards, then I think you can get away with it. The second thing is using the expertise of engineers, product designers, to push back against some of this managerial overreach, as I call it. Most companies, engineers, product people are in their own silo. They can advance through the ranks, but they're really not given a seat at the decision-making table when it comes to the direction of product decisions, overall strategy. Ironically, unlike, let's say, your sort of typical factory worker or your typical Uber driver, they have a huge amount of leverage within the company. I mean, I think we've all worked on projects where you lose one person and that sets the whole thing back months, if not years. And so if you think about the leverage that we have, I think it's more than we realize. We just have not really been able to utilize it. And I think part of that is the individualistic culture of technology, or at least how it's been for the most part over the last couple of years. You're paid very well relative to the rest of the world. You're sort of told that as long as you can code really well, you'll rise to the top. And partially that's true. But I think as we've seen with some of these corporate layoffs over the last couple of years, once it's in a company's financial interests to turn you loose, they'll do it. And nothing about this sort of meritocratic narrative is going to save you. At the same time, we've bought into it so hard that we're allowing ourselves to say, well, you know, if there's a whistleblower, if there's a walkout, and it's not exactly what I care about in exactly the way that I care about it, I'm just not going to bother with it. And so we've missed out on some of these opportunities to create this counterweight to financialism and managerialism. And I don't know if any of you were at the whistleblower panel yesterday, but I think that's another theme that came out, or even at Meredith Whittaker's keynote also yesterday. I mean, we have a huge amount of power and leverage, but we don't step into it, and it's right there. And I think the last thing is, and I know this will hurt some people, but walking away from bad employers. I know that some of them pay like $500,000, $1 million, but at some point, you've just named your price for being bought. And it's like being in a bad relationship. Oh, I can fix the person, I can fix the person. Well, probably not. But they sell you the myth of being able to do so, and they sell it to you with money and stock options. So this is kind of the capsule version of this book I wrote, and it's the reason that South by invited me back. It's called Fatal Abstraction, Why the Managerial Class Loses Control of Software. And it steps through a bunch of different case studies. Boeing and Uber are in there. We also talk about Microsoft, generative AI, and a couple of other things too, and in a lot more detail. And it's the reason that I did it is because having been in the tech industry, I just got disillusioned by the fact that we seem to be going away from the industry's utopian roots. And we've seemed to have lost the idea that technology can do good because we're chasing the amount of money that it can make us. And the more that we do that, I think the more that we'll unfortunately find that technology isn't this sort of big, liberating, essentially utopian unlock, but it's this digital straitjacket that the more we bind it to ourselves, the more it suffocates us. So, this book, I'll be giving a signing at the bookstore at 3:15. It's the only place in the world that you can get it for the next month until its official pub date. I hope to see some of you there, and in the meantime, I'll take your questions, and thank you for your attention.
Thank you, Darryl. You finished your presentation with some suggestions for us individually to act. But how about more systemic changes? Do you also go through that in your book?
Yes, I do. So the question was, we talk about specific individual actions, what about systemic ones? Let's say for the next 4 years, I'm a little pessimistic that there's going to be any kind of systemic change, at least here in the United States. I do think that there's an opportunity for regulators in some part of the world to kind of reclaim some of their power, but you think about, let's say, go back to the Boeing example. the FAA pays about $100,000 cash for a software engineer who can police some of these things that we talk about. Well, Meta pays 5 times that in base and probably another 20 times that in stock compensation. So it would take a lot of people doing a lot of self-sacrifice that I just don't really see in a lot of the industry. I'm hopeful that changes, but I do think that it becomes a virtuous cycle that if we see more pushback within the industry, then I think that will empower regulators and legislators to actually hold up their end of the bargain, let's say. Anybody else? It's back there.
Thank you. Thanks, Darryl. That was a great presentation, great talk. Coincidentally, I was also at Amazon and currently at Uber, so I think a lot of the stuff that you've talked about I can relate to. But do you have any counterexamples of when managerial class has not lost control of software?
Yeah. There's another one at the end of my book, which is actually, you remember the Miracle on the Hudson, the A320 that crashed on the Hudson in 2008 or 9? Anyway, so that was another example of the A320 was designed so that it had a lot of computer aids, but the people who designed it and who made the final decisions about the product were actually pilots and engineers. So you can see if you go deep into the details that, I remember Captain Sully, he's trying to guide this thing down with no engine power. In fact, there's a couple instances where he could have pulled back on the stick so far that the airplane would have stalled, or he made a maneuver that was too hard, and the airplane corrected for that. But when it was flaring out over the Hudson, and that was a situation that no software designer had ever thought of, at that point the software trusted him enough to essentially relinquish control and allow him to do what he thought he needed to do. So it's kind of that recognition of your own limits, that you can't have software do everything, it's not magic, but you also can use it in some ways to augment human behavior, even in ways that they don't necessarily predict. It's just a question of knowing where to draw the line. So I think that's one. It's honestly a little bit hard to find examples in recent history, but I think that's one that's pretty relevant.
Thank you. Great presentation, and definitely looking forward to reading the book. But realistically speaking, right, we live in a world, and we're in a business of making money. Every company we work for. Right, so how do you think we can achieve what you're talking about in reality? Because the numbers will always come first, right? So realistically, what can we do? I'm sure you have that in the book to really help us get to where we can focus more on quality software for those of us that are in that space and really doing what we were trained to do and still putting quality into it without, in spite of the financial decisions. So definitely, from a business perspective, they will always put the numbers first. That's reality.
Yeah.
So.
Yeah. So the question was, please be realistic, essentially. And you're totally right. I think there's a couple of things, however, that we can do other than taking that individual responsibility. So if you remember in the Boeing example, they tried to cover it up and say, oh, it's the pilots, it's the pilots. So you need people who can speak to the outside world and say, actually, it's the bad software doing it. And I think that's one potential problem with a lot of tech journalism, is that you have people who can observe and say, oh, this person made this decision. Like if you've read the recent books about Facebook or a couple of other sort of tech profiles, it basically casts them as boardroom dramas where it's like Succession, the TV show. But in fact, you need people who have that expertise to go in and critique that and say it's not just, I don't know, Mark Zuckerberg is evil or whatever, but there's actual product decisions that he doesn't see in order to kind of have some of these bad outcomes. So I think that's one. And I think the second one is being able to speak not only to the public in general, but also to regulators and legislators. So the example that I cite in the book, not to make everything aviation focused, but professional pilots in the 1930s were in a very similar situation. Airlines wanted to get as many flights in the air as quickly as possible, working pilots 30, 40 hours a day. And they formed what essentially is called a technical union. So it wasn't about wages and time off, but it was basically designed to say, look, we're getting killed at sort of 1 in 3 pilots doesn't live to see the end of their career. You need to make these decisions, and because you can't operate the airplanes without us, we have the power to push back. So I think we're in kind of a similar situation, but you're absolutely right that it's the first couple years of doing this are going to be the hardest. All right, anything else, or is it lunchtime? All right, let's get out of here. I'll see you guys at 3:15 at the bookstore in the convention center on the 3rd floor. And if anybody wants to say hi, please do so. Thank you.